So we are here continuing our discussion on parametric equations. So if you have yet to really be introduced to what a parametric equation is, I encourage you to go back and look at that video. I'll put a link here on the screen because in this video we are focusing on this concept of a parametric equation. How do you eliminate the parameter? So again, if this is new to you, or if you're new to parametric equations in general, you probably have no idea what I'm talking about when I say eliminate the parameter. So the goal here, when we're asked to eliminate the parameter, it is to obtain a rectangular equation in x and y that represents the parametric curve Okay, so we've already seen a couple of examples of parametric equations where we have an x in terms of t and a y in terms of t. So we have two separate equations. The concept of eliminating the parameter is to, maybe I could say it as combining the two equations, so where we have it as our typical y equals something with x. Okay, so it's just that we're taking t out of the problem altogether. So there are two steps to this to eliminate the parameter. Let's see what we have. So eliminate the parameter of the parametric curve x equals 1 minus t and y equals t squared plus 3. So very first thing that we have to do is solve the first equation. That would be the one that's in terms of x, or x equals. Solve it for t. All right? Solve it for t. So if I have x equals 1 minus t, to isolate t, that would mean I'm adding t to the left side. So let's do step by step here, show it to you. We have that x plus t equals 1. I added t to the left side to make it positive, by the way. And then subtracting x, so we get t equals 1 minus x, subtracting x to the right. Again, other ways of solving it, but we solved the first equation, x, for t. We isolated t. Step 1, done. Okay? Sometimes it's going to be that easy. Sometimes it's not, depending on what the first equation is. Here we have a linear equation. It's nice and easy to work with. So the second step, this is where most of our time will be spent, is substitute this expression, meaning what we had here. Substitute this expression for t into the second equation. And simplify. I was debating whether or not to make that a third step, but really, if you just did substitute as the second step, that's a really quick step. So I just wanted to put those two together. So our second equation was y equals t squared plus 3. So I'm going to substitute 1 minus x in for t. Okay. So we have 1 minus x equals in for t, and now we simplify. So let's see what we have here. So this is really 1 minus x times 1 minus x, so that would be, let's see, 1, we get negative 2x, and we get positive x squared. All right, and simplifying and rearranging, we would get x squared minus 2x plus, this is, oh my goodness, it is plus. Okay, so plus 4. And there we go. We're done. We eliminated the parameter. We have a rectangular equation in terms of x and y. So we had looked at graphing it, determining if it's a function or not. Well, you can also do the same thing by eliminating the parameter. So we eliminated the parameter and we got this equation, and this is a quadratic equation. So this is a function, knowing how quadratic equations appear graphically. So this parametric equation, let me write this, so this parametric equation yields a function, a quadratic function. Okay. And believe it or not, that's it. Solve typically the first equation for t, substitute it into the other equation, and simplify. It's that easy, guys. The only way this could become more complex is what the separate equations are. So let's see what we have in our next. So eliminate the parameter for the curve t squared minus 2, and then y equals 3t. So now, I know what I just told you. I told you solve the first equation for t. But if I solve this first equation for t, I'm going to have a positive negative square root in the end because I have the t squared. So I'm going to write this down. So since solving, this is important, since solving x for t since it would yield a positive negative square root at the end, we are going to work with y. So rather than rearranging x, we're going to rearrange y. So let's do that. So we have y equals 3t. This is really easy to solve for t, to isolate t. That's going to be just dividing by 3. So we get t equals y divided by 3. Perfect. So now, second step, put little bullets here. Second step, we're going to insert t into x, into our x parameter. So that would give us, it's, okay, so y over 3 squared, and then minus 2, all right, which yields y squared over 9 minus 2. Okay, so I'm going to come up here. So this is x still. Again, now we're trying to solve for y because we want y equals. I'm going to add 2. So we're close. So now we need to multiply by 9. Okay, so now we square root. But even still, you might have recognized it before I square rooted. Is this a function? Because often that would be the goal, is to eliminate the parameter to determine if this is a function. No, it's not. Because if you were to graph this, it would not pass that good old vertical line test. And plus the y squared, that's a great indicator that it's not a function. So this is not a function. So how do I want to write this? Not a function. Just write it that way, not a function. All right. So we had to take a different approach because of how our x component was, but really the same steps. Solve a variable for t, substitute that expression into the other, and rearrange. So let's try this one more time, where even that process will not work for us. And wouldn't you know it, it doesn't work for us when we have trig functions. So yeah, trig functions. So we have x equals 2 cosine of t, y equals 2 sine of t. In the previous lesson, we ended with a problem similar to this. If not, I think it was 3 cosine and 3 sine. So you might know already what this yields graphically. Therefore, you already know that maybe it's whether a function or not. Well, I won't spoil it for you if you don't know. So the previous approach will not work. Solving an equation for t and then substituting that into the other equation, that will not work for us here. I want to add that. So it's previous approach will not work. Because when I solve for t, we're going to have arc cosine or arc sine, and then we'll have to insert that into the other equation. It just doesn't do anything for us. So what we're going to have to think about here is, actually, let me ask you this. Knowing our trig identities, what happens when I square both of these and add them? For example, let's say I get 2 cosine t squared plus 2 sine t squared. Well, that's the same thing as saying, oh, we took x and squared it, and we took y and squared it. Okay, good. So we squared these, giving us 4 cosine squared t plus 4 sine squared t. Okay, let's just work with this a little bit. So there's a 4 in common, so we're going to pull this 4 out. And you're probably screaming with excitement. I can hear it. Cosine squared plus sine squared is 1. So we have 4. So if you already looked at our graphing lesson, you got to the end, you knew that this was going to yield a circle. This format, we know from our algebra background, this format yields a circle. This is an equation of a circle centered at 0, 0, with radius of, see, it's equal to 4, so with a radius of 2. So really, are you gonna have to do this every time? Meaning, are you gonna have to, if you have 2 cosine t, 2 sine of t, are you gonna have to do this every single time? The answer to that question is no. You're not gonna always have to do squared, squared, and simplify. What we can do here, and we'll end with this, is if I had, x equals r cosine of t and y equals r sine of t, what we can conclude is that this parametric equation will yield a circle x squared plus y squared equals r squared. Actually, no, that's not even, that is true. So equals r squared. Yeah, so as long as there's no other addition, subtraction within these components, what we have will yield a circle with this format. All right, so you're going to be practicing more with this, practicing this concept of eliminating the parameter. So follow these 2 steps. Just be careful with that initial step, what you could get that you want. You might have to work with the y component, but then when you have trig components, you might be able to skip some steps knowing what we're going to end up with. So I wish you the best of luck here. I hope this was helpful in you understanding this concept of eliminating the parameter, guys, and I look forward to talking to you in the next video where we look at possibly application, because there's really not much more to parametric equations. So good luck again, and I'll see you in the next video.